pala. Okay. So, ganun, no? Ganito yung pagta-transfer natin ng into another container. So, ano ba, ito yung reagent bottle nga natin. So, tatapatan lang natin, no, ng steering rod dito. So, doon natin pa dadaluyin yung laman niya ng solution. Okay, para dire-diretso yung pagbuhos niya. And, ano natin, controlled, no? Unlike kung di natin nalagyan ng steering rod yan, ibubuhos lang natin, may possibility kasi na maitapon natin yung solution. Okay? So, sa pagre-remove naman ng glass stopper, ayan. So, pag ganito, no? Okay? Yan. So, by using your index finger and middle finger, okay, para maiangat natin siya. Ayan. Pipette. So, ito, very common tong ginagamit in laboratory. So, dapat marunong tayo, no? Kung paano mag-pipette. So, kung small portion of liquid is transferred, then di mo naman kailangan ng quantity. Hindi mo kailangan ng exact quantity. Kung halimbawa, dropwise lang yung gagawin mo. Ito lang yung gagawin natin. Baga, hawak natin yung pipette. For example, ito, hawak mo yung pipette na ganyan. Ilalagay mo lang dun sa reagent bottle. Then, isasara mo, no? Una, nakabukas muna. Pag pinasok mo sa reagent bottle, kusa kasing magkakapillary reaction yan, aangat. So, habang umaangat, itakpan mo lang, then transfer mo. Or i-drop wise mo, bitawan mo ng pa konti-konti kung kailangan mong i-drop to a certain container, no? Or a medium kapag nagtetest ka. So, kung kailangan mo naman ng exact amount, pwede kang gumamit ng aspirator. So, yung, di ba, diniscuss natin nakaraan, yung pipe fitting bulb. So, yun yung aspirator. So, ipapump mong ganun yan. Ipipigain mo siya. Then, ilalagay mo dun sa pipette, sa dulo ng pipette. Tapos, dahan-dahan mo siyang bubuksan. Okay, dahan-dahan lang, no? Kasi pag binilisan kagad natin, pati yung sa aspirator, pupunta dun yung liquid. So, dahan-dahan mo lang siyang bubuksan. Then, kapag barely, no? Halimbawa, yung graduation mo, gusto mo 10 ml. Para sobrahan mo siya, halimbawa, ng mga 11 ml. Then, tatanggalin mo yung aspirator, saka may kakabit yung daliri mo. Then, dahan-dahan mong iangat yung daliri mo para makuha mo yung 10 ml na gusto mo. Ayan. So, sabi nga, exact amounts, kailangan natin ng aspirator. Okay? Ayan. So, kapag nagka-transfer tayo ng pipette, i-45 degrees natin. Okay? Medyo nakaganyan. Okay? Medyo nakaganyan siya. Naka 45 degrees. Kapag tinidrip na natin, no, yung solution to another container. Glasswares. So, kapag nag-handle kayo ng mga glasswares, syempre, always carry yun away from your body, no? Huwag natin ilalagay sa ulo natin, di ba? Nandito sa ating shoulders. So, pag carry natin siya is hawak natin. And as much as possible, no, medyo malayo dun sa ating body. Okay? Kapag naman, gumagamit tayo ng thermometer on a piece of glassware, kailangan meron tayong rubber stopper. Okay? Tapos, dapat ni-lubricate yung gas para hindi mabasag. Lalo na pag naglalagay tayo ng rubber stopper. Okay? Kasi may friction yan eh. So, possible, dinidiin natin yung rubber stopper, mag-break yung glass. Then, do not place hot glasswares directly on the tables. So, syempre, kahit naman sa bahay, no, di ba, pag mainit yung, di ba, nagsaing kayo, mainit yung kaldero, hindi natin directly alagay yan dun sa lamesa. Lalo na kung may tela doon, di ba, kasi masusunog siya. So, ganoon din naman, no, in laboratory glasswares. So, palamigin muna natin bago nating hawakan mga glasswares. So, tandaan natin palagi, no, na magkamukha lang yung itsura ng mainit na glassware sa malamig na glassware. So, very cautious tayo dito. Okay? So, meron namang mga ginagamit tayo na equipments na panghawak ng hot glasswares. Never handle broken glass with your hands. Okay? So, kung ba nakabasag kayo, huwag niyong i-attempt na kukunin ng kamay ninyo. Okay? Gamit tayo ng dustpan and brush. Then dispose in the cardboard container. Heating solutions in a test tube. So kapag ito, halimbawa itong drawing natin na ito, di ba? Nag-heat yan sa test tube eh. Okay, so ano yung mali dyan? So dapat daw, pag nag-heat ang test tube ay 45 degrees angle. So ang kailangan niya naka 45 degrees. No? Para nakaganon siya. Okay? Fill the test tube with half full of liquid to be heated. So huwag nating punong-puno ano, kasi tatapon yan kapag gagamitin natin yung test tube as a heating container. Tapos, dapat meron tayong test tube holder. Huwag kamay natin. Okay? Make sure the test tube is, sabi ko nga, 45 degrees. Then, place it over the flame of the burner, passing it back and forth so that the flame strike the tube just below at the liquid, but never at the bottom of the tube. Ayun. So, hindi dapat dun sa bottom. Ayan, tulad nito. Tulad nitong drawing na to. Kaya naka 45 angle siya. Okay. Dapat kasi just below the liquid level. Okay? But not at the bottom. Ayan. Punta naman tayo sa measurements. So, when we say measurement, ito yung pagko-quantify natin no, ng iba't ibang dimensions. Okay? Iba't ibang quantity. Ayan. So, meron tayong mga values no, na nakukuha dyan. And we have a lot of different measurement na ginagawa in laboratory and of course no sa real life. Okay? So ano yung una? Length. So ito, 'di ba? Kunin niyo yung height ninyo, 'di ba? Length yung mini-measure niyo doon. Okay? Halimbawa, may measure niyo yung paa niyo using ruler, 'di ba? Length yung kinukuha niyo doon. So sabi, measuring length means measurement of the length of any object with the help of measuring tools. Ayan. So meron tayong mga tools. Ano 'yan? Ruler, measuring tape. Yan, actually napakarami pa na ginagamit no in ano pag-measure no ng length. So, halimbawa itong example natin no sa pencil. Using natin ang ruler. Pwede namang ruler gamitin din dun sa students no. Matagal lang tayo magme-measure kasi ilan 'yan. Halimbawa 5, kung halimbawa 6-footer kayo, di ba? 6 na ruler ang gagamitin natin. So mas madali kung gagamitin natin diyan yung mga mahahaba na pang-measure ng length. For example, measuring tape o kaya yung metric rule para 1 meter kaagad. Okay, so paano gumamit ng ruler? Dapat dun sa zero nakatapat, no? Yung isang end up to kung saan yung dulo. So for example, to 8 cm. Kasi pag dito natin siya mineasure sa portion na to, diba ito, dyan sa measure, sa portion na yan natin siya sinukat. Mali na yung sukat natin kasi hindi tayo nagsimula sa zero eh. Bababa yan ng mga around 0.5 cm. So, mali na yung measurement natin. Okay? So, pag nag-measure tayo, make sure natin na from 0 to 0. Ay, from 0 to dun sa dulo. Okay? Ganun tayo mag-measures. Next, volume. So, when we say volume, ito yung, di ba? Ang volume ay yung space na ino-occupy ng matter. Okay? So, maraming formula no, ng pag-measure ng volume. So, ito yung pinaka-common. Yung pag nag-measure kayo ng rectangle lang, ng box, ng gift. Kung sa bahay ninyo, pwede rin i-measure yung length, kaya yung volume no, ng inyong bahay. So, ang pag-measure niyan, pag box, ganyan, pag ganito ang shape, no, itong box, ganito ang shape, is length times width times height. So, pag multiplicationin mo lang, yung tatlo na yan, para makuha mo yung volume. Okay? So, this is for regular solids. So, when we say regular solids, yung shape niya is regular and we can measure it by the given formula. For example, kung meron kang bola, gusto mo makuha kung anong volume ba yung kaya niya i-contain. Ito yung formula niya. Volume is equal to 4/3 pi r cube. So, i-measure mo lang yung radius ng circle mo. Then, times mo sa pi, which is 3.1416 times mo sa 4/3. Okay? Halimbawa, meron naman kayong mga timba dyan sa inyong mga bahay na straight dapat straight. O kaya tanks. no? Pwede mo rin siyang i-measure yung kanyang volume. Pero, not the same way as length times width times height lang. Since circle siya, gagamit ka ulit ang pi, then times mo lang yung r squared times height para makuha mo yung volume. R squared to. Okay? Para makuha mo yung volume, r squared yan, times height. Okay? So, ang volume, tandaan natin, no, ang unit ng volume, liter. O kaya, ml. O kaya, yung mga may cube. Halimbawa, centimeter cube, metric cube. Ayan. Kaya naging metric cube kasi nga, ganito yung formula niya. Nagta-times tayo ng 3 beses ng unit. Okay? Ganon yung volume. Okay, so halimbawa, prism. Yan, pwede din natin kumpitin yan. Base times height times L. Ayan, ano na ulit yan? Cubic na ulit yan, di ba? Kasi pinag-multiply natin ng magkakaparehas. Then, saka dinivide sa 2. So, kapag pinag-multiply nyo, no, halimbawa may given na centimeter, millimeter, hindi nyo pwedeng pag-multiply niyan. Tapos isa, millimeter din. Kailangan i-convert nyo muna. Either ito, gawin yung millimeter. Convert nyo muna sa millimeter. Gaya ng naging discussion natin last week. Tapos, kung ito naman gusto nyo galawin, pwede rin naman. Convert nyo sa centimeter. So, dapat pare-parehas yung unit nila kapag nagko-compute kayo ng volume. Ayun. So, I hope malinaw yan, no? Okay. So, length, ang unit natin dyan, mga centimeter, ganyan, meter, inches. Ayan. So, basta measurement, no, ng haba or distance. So, paano naman kung irregular yung solid? Halimbawa, bato. Halimbawa, bato. O kaya yung inyong kutsara. Iba yung ano niya eh. Wala siyang formula dito na pwede mong gamitin. Sound trip pa. Sound trip pa si Joanna. Okay. So, hindi mo pwedeng i-measure gamit itong mga equation na to. Yung, kutsara nga, hindi mo pwedeng i-measure yun. Kung gaano kadami. So, paano? Ano yung kanyang pwede natin gawin? So, meron tayong tinatawag na volume of irregular solids. So, yung sabi ko nga, irregular solids, ito yung hindi kabilang dito sa mga shapes na to or wala tayong way, no, to compute exactly using these equations. So, ano yung isang method? Water displacement. Okay? Ano ba yan? Paano ba yan na-discover? Kung naikwento sa inyo ng mga dati yung science teacher, no, si Archimedes, naaralan niyo pa siya, si Eureka. Diba, napasigaw siya ng Eureka. So, gusto niyang malaman kung yung crown ng hari is tama pa ba sa dapat niya. So, it took him a while, di ba? Ang story doon, it took him a while na hindi na siya naligo kasi iniisip niya kung paano niya mako-quantify yung volume ng crown. Kasi yung crown ay irregular in shape, di ba? Kung gusto mo siyang gawing gold bar, sisirain mo yung crown. So, hindi pwedeng sirain yung crown. So, para ma-measure, para ma-confirm niya kung tama ba yung crown na yun, it took him a while nga, sabi ko nga sa inyo. And sabi sa kwento, no? Hindi siya naligo for a while. Then, bumaho na siya. Tapos, ang ginawa ng mga tao is pinaligo siya. So, nung sa tub or sa bathtub, pag-upo niya dun sa bathtub, nag-raise yung volume ng water. Tapos may mga natapon. So, doon niya na-realize yung concept kung paano kunin yung volume ng irregular solids. Okay? Sabi nga dito, it can be measured using water displacement. So, paano ba yung concept niyan? Kung halimbawa kayo, kung meron kayong bathtub sa inyong mga bahay, kung gusto niyo malaman kung gaano kataas yung volume ninyo, punuin niyo na yun ng tubig. Punong-puno. Okay? O kaya kahit sa drum lang, sumit lang kayo sa malaking drum. Okay? Lagyan niyo ng maraming tubig. Tapos sumit kayo doon. Then, dun sa drum is meron kayong pang-collect ng water dun sa ilalim. Dapat ma-collect nyo lahat kasi. So, lahat ng tatapon na water, yun yung volume na ino-occupy ninyo. Okay? So, ganun yung concept, no? In layman's term, ganun yung concept ng water displacement. Okay? Sabi to, when a solid object is placed in water, the amount of water that is displaced by the object is equal to the volume of the object. Yun yung sabi ko sa inyo. Kapag sumute kayo dun sa drum na punong-puno dapat yung tubig, no? Para mas ma-visualize ninyo. Para mas ma-visualize nyo, no? Kailangan na doon kayo sa puno, no? Puno yung drum. And then yung tatapon, lahat ng tatapon, pag measure nyo, yun yung volume nyo. So, paano natin ganyan gagawin sa laboratory? So, for example, meron kayong, graduated cylinder. Ayan. So, meron kayong graduated cylinder. Tapos, meron kang stone. Okay? So, measure nyo muna. Mag-measure kayo ng liquid. Tandaan nyo kung ano yung ml. For example, dito yung ml niya is 600 ml, no? Pag dinrop natin yung stone dyan, aangat yung tubig. Okay? So, pag umangat yung tubig, pag minusin lang natin, kung hanggang saan ba yung inangat niya. Ayan, for example, 800 yung inangat niya. 600 yung pinanggalingan natin. So, 800 minus 600, ibig sabihin, yung ino-occupy na space ng stone natin is 200 ml. Ayun. So, ganun natin kukumputin kapag irregular solid naman. Okay, I hope ay malinaw sa inyo, no? Wait lang, no? Meron lang akong Okay. So, paano naman tayo magme-measure, no, ng liquids? Okay. Wait. Appear. So, paano tayo mag-measure? Ayan. So, di ba yung okay. So, paano ba tayo magme-measure naman ng colored and colorless liquids? So, pag nag-measure tayo, pag liquids, ang mga ginagamit natin dyan, yun nga, graduated cylinder, gumagamit tayo dyan ng pipette, ng burette, okay? Okay, so, halimbawa, nag-measure tayo ng clear na liquid. Kapag nakita natin, ayan, halimbawa, ganyan. So, meron niya mapo-form, no, na parang meniscus, parang na-mention ko sa inyo dati, na mayroong parang meniscus dyan. And i-measure nyo siya dito sa ilalim. Okay? Dito nyo siya i-measure sa part na to. Okay? So, ganun, no? Yung pag-measure natin ng liquids. Okay? Density. Yan. So, very useful din. Ginagamit din natin to in chemistry. So, paano ba tayo mag-measure ng density? So, una, syempre, kailangan alam natin yung weight. Kasi ang density is mass over volume. Diba? So, yun yung kailangan natin. So, kailangan natin measure muna syempre yung weight or yung mass ng substance. Using a balance. So, ayan, makitimbangin muna natin. Then, measure the volume. So, kung isang method, pwede yung displacement na ganito, water displacement. Pwede din kung regular yung shape, pwede nyo i-measure yung volume niya. Then, follow lang kung ano yung formula. For example, sa box nga, length times speed times height lang, no? Then, yung mass, di-divide natin siya by volume. So, ganoon na natin makukuha yung measurement natin ng mass at volume. Okay, so may tanong ba kayo? Any questions?
Wala po, sir.
Wala naman. So, let's watch a video. Watch tayo ng video dito. Ang mga... So, in-upload ko naman na dito sa ano nyo. So, watch lang tayo.
99 Super Shopping Day na!
Ay, wait.
Shop and check out.
The strain rod technique is a lab technique that allows you to pour liquid and minimize the amount of dripping or running over the. The strain rod technique is a lab technique that allows you to pour liquid and minimize the amount of dripping or running over the edge. Sometimes when you pour something from a beaker or a bottle, it'll run down the side of the beaker or the bottle. And so one way to minimize that is to pour it down a glass stir rod. So one way to do that is place the glass stir rod into the container that you're pouring into, and just take the other container and put it next to the glass stir rod and just pour down the glass stir rod. Another way of doing that is to place the stir rod over the beaker, hold it with one of your fingers, and pour down the stir rod.
Okay, so ganoon, no? Yung pagta-transfer ng... Wait. So, makikita nyo, yung kaninang demonstration din naman, diagram din natin. So, kaya ganyan kasi, possible kasi na, kahit di ba nag-transfer tayo sa bahay, alam mo yan, sa baso natin, pa nag-transfer tayo ng baso yung gamit. Kahit nga pitchel minsan, di ba, nagdi-drip dito yung chemical or yung solution natin. So, kaya may steering rod para maiwasan natin yung ganon. Para dire-diretso siya doon sa paglilipatan natin na container. Okay? So, anong mali dito sa professor na to? Kung hindi siya naka-gloves, hindi rin siya naka-lab gown. Meron din siyang tie. Diba? Sa lab safety natin. Okay? Ito naman, kung paano tayo gagamit ng pipette.
Welcome to the video on techniques on the use of a pipette. In this video, we will show you how to deliver 10.00 mils into an Erlenmeyer flask properly using a 10 ml volumetric pipette. First, we inspect the pipette to make sure that the tip is not chipped and the top end of the pipette is smooth and flat. If the top end of the pipette is chipped or not smooth, it is very difficult to pipette.
Okay, so pag yun nga, sabi niya, di ba, yung chip or mayroon siyang crack or broken, delikado kasi yun, no, when we're using it. So, kailangan talaga nang i-check muna kasi pwede kayong masugatan kapag ganun.
Acclimatize the pipette. Acclimatizing the pipette means to rinse the pipette with the solution to be used. In this video, we will be using solution A. When using the pipette, do not pipette the solution directly from the flask in which the solution is stored. This could contaminate the solution. Always choose an appropriate clean and dry beaker and pour a small quantity into a labeled beaker. Here we have two beakers which contain the same volume of solution A. Compare the depth of the solution between the 50 ml beaker and the 250 ml beaker. The solution in the 50 ml beaker has more depth, and it will be easier to pipette the solution out of this beaker. To fill a pipette for acclimatization, use a rubber bulb to pull up the solution. If you're right-handed, depress the pipette bulb in the palm of your right hand. Hold the pipette in your left hand, but keep your index finger near the top of the pipette. This will make it easier to put your left index finger over the top of the pipette and hold the level of the solution when you remove the pipette bulb. Keep the tip of the pipette below the surface of the liquid to avoid sucking up air and sucking the solution into the pipette bulb. The level of the solution should always rise up the pipette. The solution should not drain back into the beaker. For acclimatization, we draw up a small amount of the solution, about 1/3 to 1/2 of the bulb of the pipette. Remove the bulb and tilt the pipette horizontally to rinse the inner walls of the pipette. Make sure to let the solution slide past the calibration mark near the top of the pipette and rotate the pipette to ensure the solution touches the inner walls of the pipette. Drain the solution completely. After draining all the solution used in the acclimatization, dry the top of the pipette thoroughly, and repeat this step 3 times to finish acclimatizing the pipette.
So tayo naman ay, ito kasing ginawa niya is parang ni-rinse niya na yung pipette para maiwasan natin kung meron man na contamination. Okay?
Pipette and deliver 10.00 ml of solution A. Fill the pipette with the solution past the calibration mark. Remove the bulb and quickly place the index finger of the left hand over the top of the pipette to hold the level of the solution. Tilt the pipette slightly and wipe away any liquid on the outside surface. Using the same hand, place the pipette between the second and third finger to support the pipette and pick up the beaker to bring the pipette calibration mark to your eye level. Slowly release pressure on the index finger so that the bottom of the meniscus approaches the calibration mark at eye level. At the mark, apply pressure on the index finger to stop the level of the solution such that the bottom of the meniscus is sitting on the calibration mark.
Okay, so yan, pag kasi na yung pipette nyo is hindi kasi nakikita sa taas, no? So, kasi sabi ko, di ba, kung ano yung gusto ninyong graduation ay lalagpasan nyo yun kapag nag-aspirate kayo, no? Or sinak dito yung solution. Then, slowly, bubuksan mo ng dahan-dahan. Okay, bubuksan mo para yung hangin kasi parang yung hangin ang magpapababa dyan yung hangin. So babagsak siya. Kapag malapit na doon sa graduation, saka nyo tatakpan ulit ng inyong daliri.
Mark. Inspect the tip of the pipette to make sure that it doesn't have a hanging drop. If there is a hanging drop at the tip of the pipette, touch the tip of the pipette on the wall of the beaker and recheck to ensure that the position of the meniscus has not changed. Now you're ready to deliver the solution into an Erlenmeyer flask. Bring the pipette to the Erlenmeyer flask and release the pressure on the index finger. Drain the solution into the Erlenmeyer flask with the pipette tip touching the wall of the flask. After draining, wait 10 seconds before removing the pipette. At this point, the calibrated amount of liquid has been transferred. Look closely at the tip of the pipette. A small portion of solution remains in the tip. Do not blow out the pipette. Thank you for watching the video on techniques on the use of a pipette.
Okay. Next natin, last na video.
My job is to make college easier because students have a lot on them.
Just to talk about the types of measurements that we
Ayan,
make in
so
chemistry.
iba't ibang
Specifically,
measurement,
I'm
no?
talking about quantitative measurements. We've talked a lot about qualitative measurements over the last few days, so quantitative measurements it is. In general, in chemistry, you're going to be working with 4 main types of measurements, quantitative measurements: length, mass, volume, and temperature. That's essentially it. So, to make each of those measurements, you need to know which tool to use. To make measurements of length, you're going to use a ruler. We typically will always use the centimeters side. We work exclusively in the SI system, the metric system. So you'll be measuring in centimeters. And we're going to learn how to make better measurements with this ruler as we go through our measurement unit. To measure mass, you have two options. You can use this. This is a triple beam balance. And it operates similar to a doctor's scale. It has these sliding weights along 3 beams. And I'll show you how to use that. You also have the option of a digital balance. Digital balances are pretty easy to use. You just put the item on the balance pan and read the display. Pretty straightforward. To make measurements of volume, we use something like this. This is a graduated cylinder. It's nothing more than a long container with lines up and down the side of it. And the lines allow us to measure the volume of the liquid inside. Now, there's a little trick that you have to be aware of when using something like this, especially a graduated cylinder made out of glass. There's a specific way I want you to learn how to read it, and I'll show you that in just a second. And finally, to make measurements of temperature, we use a good old-fashioned thermometer. We'll be using alcohol-filled thermometers, not mercury thermometers in this class. And we'll take a look at the scale, or the lines on this particular instrument as well. So those are the 4 measurements that we're going to be making: length, mass, volume, and temperature. And we're going to talk a little bit about each of those and some specifics on how to make those measurements now. Let's start by taking a look at the triple beam balance. The triple beam balance is named because it has these 3 beams. There's tens, hundreds, and units of grams. And there are these sliding weights that slide along the beams. So the idea here is we put something on the balance pan, the arm goes up, we move these beams, or these weights, to try to get the mark to come back down again. Okay, it's very simple. So this is going to be a little bit more than 50 grams. You can see 50 grams almost gets it perfectly. I can add just a little bit more from here, and the marks will match up. It's very simple to use. The key is getting the marks to match exactly right. Using a digital balance couldn't be easier. The only thing you really have to do is make sure that it's at 0 when you start in the display. And the way to do that is to find the button that either says 0T or tear and push that, and it will 0 the scale. Then all you have to do is put your sample on the balance, and it'll read out on the display. Usually a little mark will appear when it's stable, and you write that down. Couldn't be simpler. When you're measuring volume with a graduated cylinder, it's pretty straightforward, but there is something you need to be aware of, and that's the meniscus. If I come in close on this, you'll see that the top of the liquid is a sort of curved bowl shape. You'll notice also that the bottom of that bowl shape is actually below the line. It sort of shows up between 2 lines on the graduated cylinder. I need to measure the volume from the bottom of that bowl shape, the bottom of the meniscus. That's where the volume is most accurate. So if you keep that in mind, you'll never make a mistake. Using a thermometer should be pretty straightforward, and many of you have done it before. You simply read the measurement at the top of the red line. The red line is alcohol, not mercury. We don't use mercury thermometers for safety reasons. But this is good enough for what we'll be doing, and you just simply need to see where that red line ends to make your measurement. We will talk a little bit about what happens if it ends between lines, but for now, you just want to be able to use the tool. By this point in your schooling career, you've definitely used a ruler before. Just a couple of things to remember: in science, we always use the centimeters. We don't use inches. More importantly, when you make a measurement with a ruler like this, your measurement, the unit, will be centimeters, which means that each of these little lines, you know that they're called millimeters, but each of these little lines are now tenths of a centimeter. So if I have this line that's halfway between 2 and 3, I say 2.5 centimeters, because
0.5 is half a centimeter, and so that line is there. If you're only 3 lines over, it would be 2.3 centimeters. Other than that, just make your measurements in centimeters and you should be fine.
Yan, okay. So I hope na naunawaan ninyo yung topic natin for today. And ganun ulit, meron tayong laboratory activity. Okay, it's all about measurement. So before you answer this, meron lang akong ilang reminder sa inyo. Please, kapag kasi 'di ba pag nagla-lab sir tayo,